Hello friends, welcome. Friends, in my channel, my endeavor has been to explain things as simple as possible without going into technical jargons. The idea is that you get a flavor of things rather than you becoming an expert on technology. That is not the intent. So friends, I have taken issues which are of interest and I do various kinds of flavor of videos. Some are regulatory in nature, some are judgment, some are technology centric. Now, while I have done certain technology centric video, I found that lot of questions have emerged because of those videos. Like people want me to answer some fundamental questions. And then there is one important thing which people have not been able to understand is that why 5G has not been able to present itself to the operator so that they can monetize it. And that has created a huge amount of, you can say, dampened spirit about modern technology and questioned the next evolution of technology to 6G. So friends, in order for me to make sure that the viewers have a very clear understanding on the overall dynamics of technology development, what were the technology drivers, what led to development of certain technologies, and what were the reason why certain technology became superstar. They were able to drive tremendous value, and some technology became completely useless and it really didn't drove any value. It kind of became a burden on the operator. For example, 5G. So friends, you will find this video very, very interesting because this video is going to take you from 2G till 5G and in future 6G in a very short window of time without going into details about each and every technology. The idea is to focus on key important points which you will find very interesting and it will resonate with your thought process, and you will be able to understand that what are the challenges the operator face in order to provide you service, and why are those challenges being seen in the current scheme of things. So friends, I have created a slide deck in order to streamline my thoughts so that I don't digress into a different direction. So here is the opening slide, and the title of the presentation is Why Wireless Technology Evolves and the Real Story. So here, these are the points which I'm going to emphasize on: understanding the engineering drivers behind 2G to 5G, what problems each generation of technology try to solve, speed, latency, efficiency, why some generation created massive value, for example 4G, and why other technology like 5G faced monetization challenges. Though there were huge aspirations, value, excitement about 5G, but 5G didn't deliver any value, especially for India. And I'll explain to you why. And what this means for future technology like 6G and beyond. So the purpose of this discussion is to kind of emphasize one single important point, which people kind of get there's a complete misconception. Let me explain this. Whenever we talk about technology, wherever we talk about the latest in the best technology, we always get carried away by speed. Actually, speed is not the foundational factor on which technology should be judged or measured. The effectiveness of the technology should be measured. The wireless evolution is not about higher speed. It is about improving operators' service delivery option, because we always get hung up on speed. Speed is a very, very important factor, friends, but in a different setting. For example, if you are using computer, broadband, watching high definition video in a higher form factor like TV, a big screen, speed becomes very, very important. But in the form factor, which is a mobile phone, speed is not the only thing which drives user experience. It is completely different. Speed, even if you have a reasonable speed, your user experience can be very, very high if the quality of service delivery is of an international level. And I'll explain to you why service delivery is not of an international level, and therefore whenever TRI measures speeds, it is not the factor which should be considered to evaluate a wireless network. It should not be, right? And I'll explain to you why. Every generation involves trade-off, cost, performance versus capacity, coverage versus capacity. Why 5G is a turning point, solved some issue but created some new ones. Lack of coverage and spectrum constraint make monetization difficult. Lesson for operators, regulators, and policymakers. Right. So, mobile technology evolution overview. We all know mobile technology evolved from 2G to 3G, 4G, 5G, and now future 6G. And everybody gets carried away whenever there is a new term, right? Most of the time, the operator use these terms for marketing purpose, right? It does not make, so you can say 5.5G, 4.5G, LTE plus, LTE advanced, all these things are sometimes, it's a marketing term most of the time. It is driven by higher throughput and lower. So the driver is that we need to get higher throughput. Why higher throughput? Because if you get higher throughput, then you will be able to serve large number of customers at a reasonable speed. Suppose the throughput is less, everybody sharing the same block of spectrum and the same RF beam, then their individual speeds are going to go down, and therefore we are always looking towards higher throughput. Speed is a direct, there is a direct relation between speed and throughput because it is a shared spectrum. It's a shared bandwidth, okay? And there is always a need for lower latency because the response time has to be better. If you give a command, you should get an immediate response. And if you have to wait for 5 seconds or 6 seconds, or maybe even 1 second, your user experience goes down. So the core problem is to increase speed. And for increasing speed, you need more bandwidth. And more bandwidth is always available at higher frequency. Higher frequency have got poorer coverage, and therefore poorer coverage means very, very dense network, and operators are not willing to make that investment, and that creates a monetization challenge. You understand now why this? So this thing, you just pause the video and look at it, and you will understand the complete problem from here. This particular bullet, core problem, right? Now let's talk about GSM. Then you will understand, how the technology evolution took place. And I am not going to go into much detail, but you will understand how GSM, CDMA, and other things evolved. So the GSM thing was a kind of an emulation of wireline. And let me explain what I basically meant. So before GSM, everything was wireline, nailed up connection, just like this cable. You see, copper cable. So you have got these strands, strand number 1, strand number 2, strand number 3, strand number 4, 5. So there are multiple strands, right? So GSM also emulated this concept. So they used the wireless carrier, 200 kilowatts of width, and created time slots, 8 time slots each in this carrier, and which resembled something like this. Means every user would get a nailed up connection in the air. So it's like saying that, let's say if you make a call, your call is going to go through, and this particular channel that I am showing you is going to be held by you when you're talking. It's not going to be given to anybody else. And that made the technology quite inefficient. So therefore, for an analogical purpose, I have drawn this copper cable. It's almost similar. So one particular cable, strand of the copper cable is dedicated to you. And that is the reason why GSM was very, very inefficient. Now, what CDMA did, CDMA came out with a complete revolutionary concept. So there is a bandwidth, let's say, of certain size. And every user used to use the complete bandwidth. So it's like saying that, whenever you are using a CDMA technology, instead of breaking this into individual slots, you end up using the full bandwidth. So the technology evolved in such a way that the number of users that this bandwidth can support was dependent upon the increased noise floor. Because more the number of users that you support, the more the noise floor will increase. So if the noise floor increases to beyond a certain threshold, then your capacity is going to get constrained and you could not go beyond that. So that is the simple concept of CDMA. And since CDMA, nobody held up a particular time slot, therefore, everybody had the full, bandwidth available. So if somebody is not talking in the between or is not using the channel efficiently and is kind of, idle for that moment, somebody else will get the channel. Therefore, it became much more efficient. WCDMA, and which is called 3G, was almost similar to that of CDMA. Therefore, I'm not repeating. It was 1.25 megahertz and this was 5 megahertz channel width. It's almost similar. Why there were two different flavors of CDMA? Because this CDMA was promoted by 3GPP2. WCDMA was the GSM guys promoting a migration to a next generation technology. So because there were two different paths of technology evolution, one was developed by CDMA, another was from the GSM set of companies, and therefore they adopted a different channel size. Otherwise, fundamentally these two technologies are similar in nature. Now come the LTE. Now from here you will understand 4G and why 4G became so important. Now what happened was that in case of CDMA, the bandwidth that you could use at a time was 1.25 megahertz. Why? Because if you had pushed for a higher bandwidth, the spillovers that you see here, they became very prominent. The filter design became very, very important, and that limited the size of the bandwidth, and you could not aggregate large quantum of spectrum because of these spillovers. The filter design became the barrier and the cost factor. Similarly, in WCDMA also, there was a 5 megahertz channel size. You could not have gone beyond 5 megahertz because the filter was like this. And since everybody is using the full bandwidth, therefore, this spillovers became a very, very important problem. So if you had stretched this bandwidth for a larger size, then this spillover would have become very large and it would have disturbed the channel which actually lies here, right? Therefore, now, in order to solve this problem, LT came out with a completely different type of, coding structure, right? Which is the physical frame. They call it OFDM, OFDMA or OFDM, which is here it was 5 megahertz, here it was 20 megahertz. So what they did was they chose a channel of 20 megahertz and broke that channel into individual sub channels, right? Which was like orthogonal to each other. So now it's a little difficult concept. Be with me. I have not drawn the orthogonal diagram here. Otherwise, people would lose me. I wanted to do this video for people who do not have any understanding of technology. So just be with me. These are orthogonal channels. Orthogonal means what? Orthogonal means basically like this, that the peak of this channel, there is a response of every channel, right? This is a response, which is called filter response, which is the peak of this channel actually was placed in such a way that as it goes down, it was centered. It was the bottom of this channel coincided with the peak of the next channel. You understand why? So because it was like this, it will be very difficult for me to explain like this, but just to make you understand, this block was positioned in such a way that it naturally did not interfere with this block. Just understand this. Otherwise, it will become very difficult to understand. It naturally did not interfere with this block. And therefore, instead of having a full block like this, you had sub-blocks within a block of 20 megahertz, which were positioned in such a way that they don't interfere with each other. Right? This was the technology. And user, if they wanted certain amount of channels, let's say if you want the greater throughput, you choose 3 blocks. If you want a more, you choose 5 blocks, like that. But you had 20 megahertz of spectrum to work with. And there were multiple such slots. Depending upon your throughput requirement, you chose a particular block size. And that kind of increased your throughput. If your throughput increased, then because the spectrum is common for everybody within that cell. So if you have a cell like this, cell of certain like this, and people are residing in their cell, like all people are residing in the cell, they use a common spectrum, and therefore, if you have a larger block of spectrum, your throughput increases. Now, what 5G did? What 5G actually added a time domain multiplexing also, because these blocks were physical, in the physical space, or they were they were physically separated. They were not time division multiplexed. So what did you do? You created time division multiplexing slots also. So added one more dimension. Now, what was the advantage of adding one more dimension of time domain? So the slot size that you had, here the slot size were little bigger. Means larger the slot size, the response and the latency increases. Because you have to pack all those slots before you transmit the frame. And therefore, when you receive the frame, the slots have to be packed completely before you receive it. Shorter the slot, better is the response time, because then you don't have to pack so many time slots before you send the response and receive the response. So therefore, when you broke this into time domain multiplexing and create and refine the slot into smaller width, your latency became better. And you created a certain kind of structure where you could aggregate more than 20 megahertz of bandwidth, which is, let's say, 100 megahertz of bandwidth. Here, you could only do 20 megahertz in 4G. In case of 5G, you could aggregate 100 megahertz of bandwidth. That is what the enhancement was. So target was, what was the target? Target was high bandwidth, low latency, massive connectivity. That was the target, because more the bandwidth, more the throughput. And more throughput means you can serve more number of customers of a reasonable higher speed, right? So this is how it is. If you see channel bandwidth, how evolution, 0.2 megahertz, 200 kilohertz in case of GSM, 1.25 megahertz in case of CDMA, 5 megahertz in case of 3G, 20 megahertz in case of 4G, 100 megahertz in case of 5G. More the bandwidth, more the throughput. And why it was like that? Why bandwidth and throughput were proportional to each other? Because the efficiency of your system, or if your technology, did not increase significantly after 3G. It was almost like 4G was just 20% more efficient, 5G was a little bit more efficient. So after 3G, the efficiency did not increase much, and therefore you needed more bandwidth in order to increase your throughput. So challenges beyond 3G. After 3G, spectrum efficiency plateaued. Higher speed needed large bandwidth, 20 to 30 megahertz, high frequency 3.5 gigahertz plus don't penetrate indoor. So as you went to as your frequency requirement, bandwidth requirement increased, you have to go to higher frequencies, because you could not have got those higher bandwidth with low frequency band. Therefore, you were pushed into the higher frequency band, and those bands did not penetrate indoors. So this is how the spectrum efficiency chart looks. 2G, this was this. I didn't draw this. I just gave you an indicator, right? It did not draw the unit here. So just you can understand how the frequency increased over generation. The efficiency of spectrum efficiency increased over generation. Now, why monetization is difficult in 5G? Now, this is important now. This is getting very interesting now. What happened in case of 5G? As I told you, as your urge to get more speed, more throughput, you needed more bandwidth. And those bandwidth you can get only in 3.5 gigahertz spectrum, 26 gigahertz spectrum, higher frequency spectrum. Because lower frequency spectrum like 700, like 800, 900, the quantum of bandwidth is very, very less, right? So one operator will get 10 megahertz, somebody, if you're lucky, will get 20 megahertz. So if you have such a small bandwidth, then you will not be able to drive huge speed. You can only drive that at higher bandwidth, which is available in 3.5 gigahertz or higher frequencies. Now, the problem is that it's kind of a paradox. As you go higher frequency, you get better bandwidth, but your coverage becomes a challenge. Because frequency, if you go here, I'll show you the diagram here, frequency versus coverage. As you in the lower frequency, you get a better coverage. But as your frequency increases, your coverage goes down. Now, if your coverage goes down, then what happens? Then it becomes a very dense deployment, and operators are not willing to make that kind of investment. You require a large number of cells. Your existing cells that you have for 3G or 2G or 4G is not sufficient in order to drive a 5G network. And people are not willing to make that because it will become very, very expensive, and every cell site will require a fiber backhaul. And that becomes a limitation because we don't have a dense fiber network in India. Without a fiber backhaul, you will not be able to aggregate that data and carry it forward for processing. So that is where the problem is. And then in the low frequency band, the spectrum management is so messy in India that an operator, in order to give you a reasonable throughput, right, and a better quality like HD voice, etc., he doesn't have spectrum. Reliance only has 10 megahertz of spectrum. Bharti does not have any low frequency spectrum for 5G. Vodafone does not have. BSNL has 10 megahertz. If you really want to give a very good quality 5G, right, to the users, it is not about 3.5 gigahertz band, friends. It is actually about low frequency band, and a per operator minimum should have 20 megahertz of spectrum. Ideally, best situation should be that one operator should have 25 to 30 megahertz of spectrum, because more spectrum that you have in the low frequency band per operator, sorry friends, better you will be able to drive throughput and your quality of service will increase, and all those differentiated services that you want to do, where you want to differentiate users. Some users will get fast lane, some users will get different type of SLA, some users are going to be best effort users. Those bifurcation can be easily done without congesting those value users who don't want those premium services. That is the major reason why 5G is not monetizable in India, because in India you don't have that kind of base station density deployed. 3.5 gigahertz does not penetrate indoor, and low frequency band is not given. The prices are very, very high. Operators do not have low frequency band. So the role of spectrum and regulators, it's very, very important, because spectrum, oxygen for telecom operators, affordable low band spectrum is vital for India, because of the reason that you need 5G to be monetized at the handset level. At the FWA level, 5G cannot be monetized because the volumes are going to be low, capacity requirements are going to be very large. I already have explained in one of the FWA video where I measured how much subscribers Reliance will be able to support in their network. Though they are claiming 100 million, as per my calculation, in the current base station density, they can't even do 10 million if you are guaranteeing 100 Mbps per user, right? So therefore, affordable low spectrum bands are vital for India. Efficient spectrum policy is key for 5G and 6G success, which I've already showed you. Future outlook and 6G. 6G will face similar challenges if spectrum is inefficient. Tech may improve the band aggregation and duplex losses. So duplex loss is very important. I did not mention in this video, friends. Let's say if you have spectrum in two different bands, 800 megahertz and 700 megahertz, 10 megahertz each, and you said that let me aggregate this two spectrum into one single 20 megahertz. It is not possible, friends. It is possible, but it is going to undermine the coverage of both the spectrum band and reduce it by 40% or 50% because of this diplexer loss. It is actually misspelled here, diplexer loss. And this diplexer loss, because the spectrum bands are close to each other, you need to have a very, very high quality diplexer in order to carve out and separate those RF signals which are emanating out of these two different bands. And therefore, ideally, for one particular operator, one single band should be given in order to fully monetize 5G. You can't really say that I'm going to go 10 megahertz here, 10 megahertz in 800 megahertz, in 10 megahertz in 700. Bharti will have 10 megahertz in 900, 10 megahertz in 600. That's not the way it works. And therefore, spectrum management is extremely crucial, friends, for success of 5G. In future, maybe 6G will be able to resolve this diplexer problem. I do not know what kind of technology evolution will take place. But in 5G, the reason it was not monetizable is because people did not care about managing low frequency spectrum band. They were only going and bothered about 3.5, 26 gigahertz band. And you can see that even if you get 100 Mbps and 400 Mbps or 300 Mbps in a handset, you cannot actually able to enjoy any new application. Because for you to get a new application, you need to differentiate. You need to provide different type of SLAs. You need to provide fast lanes, which are only possible when the signal travels ubiquitously indoors in your house. It should not get stopped, or you should not, the signal should not fall, just short of your in house as you enter your house, because then you will not be able to use that service end to end. You cannot do it through Wi-Fi, because Wi-Fi is a different network altogether. Your 5G should natively travel indoors, friends. And that's why low frequency band is extremely crucial. I have been saying this from the very beginning. And because of that, 5G is non-monetizable, because in the handset are affordable devices. The prices can go down to 5,000, 4,000 rupees. FWA prices are pretty high, right? ARPUs are also very high. People don't afford it. So only way 5G is monetizable is at the handset level. And for that, you need large quantum of spectrum, at least 20 to 30 megahertz of spectrum per operator, in order to create a better quality service compared to what you have been able to deliver 4G, and differentiated service with different SLAs to each and every individual and charge them premium. Thank you, friends, for your time. I hope that you like this video. It gone a little overboard than what I have planned, but this was a very important topic. And if you have any question, let me know in the comment section. I will answer them. Thank you for listening till the end.